on mesh current analysis. So the aim of the experiment is we'll be finding the currents Ix, Iy, Iz, and also we'll see how do we simulate for power. So this is your circuit. This is your circuit diagram. Let us see how do we calculate theoretically. So here the orientations of currents are given, as you can see, Ix, Iy, Iz. So the number of unknowns by mesh current analysis are. Now, by inspection, we can relate any current source to your mesh currents. We have two currents there, 5 and 6 amperes. So if I can ask you a question, out of these two currents, which mesh current can be associated with 5 or 6? So it's clear that we can say this current IW we can associate explicitly for 6 amperes, right? Thus we can say IW is equal to 6 amperes, right? Thus we'll not be applying mesh current analysis to this mesh or loop. Thus we can say the number of unknowns are now 3, not 4, because we have inspected and we have related the current to one of your meshes. But why can't we relate 5 amperes? Because we cannot say explicitly that 5 amp is equal to Iy or 5 amp is equal to minus Iz. So when we are in such dilemma, we have to apply super mesh. That is, the definition of super mesh is a current source either dependent or independent between two meshes. Those two meshes have to be applied KVL together. That is, simultaneously one is to apply KVL or mesh analysis for Iz and Iy here, right? That is how we can equate it. So we cannot say Iy as 5 and neither we can say Iz as minus 5 explicitly. So we have to integrate both and rewrite the equation as Iy minus Iz is equal to 5. And that's your first equation. So I repeat, the number of unknowns are 3, which are nothing but Ix, Iy and Iz. And thus we need 3 equations to solve. And in all the 3 equations, we'll have the variables Ix, Iy and Iz. So we have got one equation. So let us see the other 2 equations. Now as told, the number of unknowns are 3, the number of equations to solve are 3, and we already have one equation. Let us solve the other 2 equations. Now let us apply super mesh. So how do we apply super mesh? You have to remove the complete branch which is responsible for super mesh. Which branch is responsible? The 4 volt and 5 amp branch. So we eliminate that 4 amp and 5 amp branch and apply super mesh. Right? And we again apply super mesh in clockwise direction, right? And this is your equation. So 10 Iz plus 4 Iz minus Iw plus 5 Iy minus Iw minus 2 Iz plus 3 Iz minus Iw. So when you are applying super mesh, one can observe the value, the orientation of Iz is clockwise, right? So here Iz will be at higher value compared to your Iw, right? And similarly at this mesh, Iy will supersede your Iw, and at this, when you come here for 3 ohms, the Iz direction matches with your super mesh, and that's why Iz is positive and Ix is negative. So when you come to Ia, here it matches with Ia, and that is why Ia is positive, whereas Ix is traveling in opposite direction, Ix will be negative, right? And then for this 5 ohm, your super mesh is going downwards and your Iy is also going downwards, and that is why Iy will be positive and Iw will be negative. But here this is an voltage source, so you need not actually incorporate your current. You can directly write that as 2Iz. Now but here we have Ia, then how are we writing Iz? Because in this branch current we have Iz, in this branch current we have Iz, and that orientation matches with your Ia current. Thus one can say the value of Ia as Iz. And from this, when you simplify, you'll have equation 2. And then the third equation, one is to apply at mesh 1. And this is your equation for mesh 1. 3Ix minus Iz. Why Ix is positive? Ix is positive because the orientation of clockwise current, right? And Iz current is flowing in opposite, and that is the only reason why Iz is negative. And as a current, it hits positive here, and that's why we incorporate plus 2Iz. And according to the clockwise current, it hits negative of 4 volt. That is why we write that as minus, right? And when you simplify, we have equation 3. And as you solve using simultaneous equations, you will get Ix, Iy, Iz as shown here. Now let us find out power associated with two elements, one with respect to 3 ohms, another with respect to a current source. So the formula for power is, there are 3 formulas for power, but the best suited for passive elements, that is for your R, L and C, the best formula would be I square into R. So R is 3, the value of current is the branch current, the current flowing through 3 ohms. So it's a combination of two currents, Ix and Iy. So Ix is also flowing through 3, Iy is also flowing through 3 ohms. Thus you can say that as Ix minus Iz or Iz minus Ix, because we are squaring the value of current, thus any orientation should not be difficult for power. Next, how do we find the power associated with 6 amperes? One has to find the voltage drop across your current. Right? How do you find voltage drop across current? So it is when you open circuit your current source, right? So when you open circuit your current source, you find the voltage drop across 4 and 5 will appear across 6 amperes. So what is the voltage drop across 4 ohms? It is 4 into IW minus IZ. So I have considered as IW minus IZ, and accordingly I will be marking the polarity. So I have considered IW, and that's the reason I will be marking positive here and negative at this end. If I consider IZ minus IW, I will be marking positive. I will be marking positive here, right? Positive here and then negative. So based on the orientation of current that I have chosen, I will be marking the polarity as shown here. Now similarly, voltage of across 5 ohm, it is 5 into Iy minus IW. So since I have taken IW minus Iy, I'll have positive at the bottom and I'll have negative at the top, and the value is minus 3.68 volt. Now as you apply KVL, you'll get the answer as minus 13.376 volt. So we have done all these in your numericals. So still if you have doubts, you can kindly revert. Now, so you can see here, I've just represented it explicitly. The value of voltage is minus 13.376 and the value of current as 6. Accordingly, substitute the values in your formula. That is P bracket, the polarity, and then the value of current. So voltage is minus 13.368, and we have written that. And the value of current is 6, we have written that. And in the parenthesis, you have to substitute the current, where does your current hit, or which polarity of the voltage does your current meet. The current hit is positive polarity first. That's the reason why it is positive. Now, let us see how do we connect this in PSpice. So before we go to PSpice and actually solve, so it's more keen to understand how do we actually connect your dependent source. So rest all components you are aware, because we are already into 4th experiment. So I am aware that you'll be able to get the parts and connect it. But how do we actually connect your dependent source? So let us try to understand with your circuit diagram and the actual part in your PSpice. So this is your dependent parameter. There is dependent voltage source depending on current, or current source depending on voltage. 2 is your gain. So how do you enter the value of 2? That I'll be showing you in PSpice. Now, so the one which is in your rhombus is your voltage source. The one outside your rhombus is your dependent parameter. Let us try to compare that with your PSpice. The one which is circled is your source. The one which is not encircled is your dependent parameter. Now this Ia has to be synchronized or connected to the value of Ia shown through 10 ohms here. Now how do we connect this? So the part name is H in your PSpice. Now positive is connected at the top. You can see here the positive is connected at the top. So similarly in your PSpice you have to connect at the top junction between 3 ohm and 4 volt. And negative in the circuit diagram is connected to the bottom. Similarly here negative is connected at the bottom. Now where exactly is Ia? Now this Ia is the current flowing towards the right side in your 10 ohms. Now how do we connect this? We've seen the calculations, we have taken Ia as Iz, but how do we connect in PSpice? This Ia orientation you can see it's going down. That arrow mark has to be integrated or connected to the arrow mark shown above through 10 ohms. Then how do we connect? So you have to, how do we connect in current source? We always connect a current source in series, voltage across. So you have to cut a wire for 10 ohms I'll show you the two ways, I'll show you both the ways, and whichever is easy for you, you can adopt. This orientation of current should match with the orientation as shown above. Then how do we connect? So current has to go through your dependent parameter, and from there it has to go to your 10 ohms. So this is one way how you can connect. Now, how do you enter the gain 2? That I'll be disclosing when we go to PSpice. So this is not the only way how you can connect. So let's see the other way around. How do we connect? So you can see here now I'm cutting the wire after 10 ohms, because we know the current is still traveling right, and it is the same current traveling even after 10 ohms. Thus I have made a cut. I have cut the wire after 10 ohms, and see how do we connect this. So the current will flow after 10 ohms through your dependent parameter, and from your dependent parameter it will flow, and thus completing your circuit. So these are the only two possibilities how you can connect. So now let us see the circuit connection in PSpice. These are the part names that are required. So as per the diagram, one can observe here 1, 2, 3, 4, 4 passive elements, so 4 resistance. We have 2 current sources, the part name is IDC. We have 2 voltage sources of 4 volts. So we have 2 voltage sources. And the part name for your dependent, it's a voltage source depending on current. So we call this in two ways: current dependent voltage source or voltage source depending on current. What is this two? As discussed earlier, this is your gain. One common ground point. Right. So let's get the parts in PSpice, and then let us see how do we connect and simulate for your results. Now, so as you open the schematics, let us arrange and see how one can connect this. So let's get the part. First is R. How many we want? 1, 2, 3, 4. 4 elements. So as you place them, as you inline to your circuit connection. Control R is your keyboard shortcut to rotate. And then we need 2 IDC. So part name is IDC. And place them according to the diagram. Then you can just escape or right click once you've done with the requirement of components. Then 2 VDC, type the part name is VDC. Place them according to the diagram. Circuit. Control R to rotate it. You can see positive is taking the current source, so control as it is. And then the part name is H required for part, current dependent current source. So you can see that in library, type H, you can read the description, current control voltage source. So the voltage source is within your ROMs, and the current control parameter is your IA. So place and close, where we have to place, we place it here. And then we need the common ground, the part name is EGMD. Thus we have got all the components required. Let us zoom in to fit page. Then let us value them. This voltage is 4 volt. This is 3 ohm. This is 10. This is 4 volt again. This is 5 ampere. You can move your values at the top. So you can call me a 4 volt and 5 ampere at the top. And then this is again 4 ohm. 6 ampere. This is 5 ohms. Now, we've given all the data. Let us try to connect them. Control W is a keyboard shortcut. Wire. We connect the dependent element. After this, right. So you can rearrange. Now, so there is this plus connected. So you can see, let me zoom in this much to explain here. So here positive dependent source is connected to a junction where 3 and 4 are negative, connected, negative of 4. So this positive has to be connected where? At the top. And negative is connected at the bottom, and this is connected at the bottom. And what is the gain? The gain value is 2. So double click on each parameter, default value is 1, change this to 2, click on save attribute and OK. Then, how do you connect the current? This IA direction and this IA direction both should synchronize. Since this arrow is going down, it should actually be here. Since you have to connect. Now how can this be connected? So IA is here. Right? So the value of IA is here. So let me write the arrow mark for that. So this value of IA, it should be in this direction. So this arrow should synchronize for this value of IA. You need not do this, this is only for me to explain. And how do we connect? So we know current, so always we connect in series, current ammeters. So the current flowing in this branch, right, that should synchronize with this current. So the current in this direction has to flow to this dependent source. So what we do when you observe the 2 ways of connection, are doing it in only one way. As explained previously, we have done organize that circuit in 2 ways. So I do it in one way, delete this wire. Now the current should come through this. So the current, now if you see, if I make a connection here, at the blue line, it creates a junction. Let me zoom in and show you. So if I make a connection here, it will create a junction at this end. I hope you saw that. And that will be an error. So to do an error connection, the best option is always move apart from your ends of your elements. Or you can also travel in between. Okay? But not at the ends of your elements. Okay? So I'm going to put this. And then from this, it has to go. Right. So now we are actually connected as per our electric circuit. So the current, you can see IA current, it travels from this junction, it moves right. But the value of that should be incorporated in a dependent source. This is how practically the circuit will be connected. Current flowing in this branch, it flows to a dependent parameter, that into multiplied by the gain 2, and then it flows to your terms. The direction is correct now. Let me just show you an incorrect connection. I'll just show you how you should not connect. So Control W. This is just negative of that or opposite of that. Now see the current IA. We want the current going in this direction to be connected to your dependent source. Now you can see the orientation of current is in the other way. See this current is going right, but you can see it's not the same orientation of IA connected. It's going in opposite direction. How you can see that the current we want in this connection, but the current flows in this way, but you can see it's going in opposite value. Opposite direction. So all these are vectors. Direction of orientation is very important. This is incorrect view of connection. Right? This is the correct view. The current going right, yes, is also matching here. It's going right or going downwards, or the orientation of arrowhead, and then it passes through. Right? So then let us save the file. Once you save the file, what all we have to find. Right, so let's see what all we have to find. Right, so the typical values are for Ix, Iy and Iz. Now, so where one has to connect to find Ix, Iy and Iz. So I think this is your red color is Ix, this is Iy, so this is Ix, Iy and Iz. So then how do we place the current markers? Now, which current is where is current Ix flowing? The current Ix is flowing through 3, 2 Ia as well as 4. But which branch current will give you the mesh current. I repeat the question here. You have to analyze for which branch current will give you the mesh current. If I place my current marker at 3, so let me do that. So this is your IX part. So if I place my current marker, you can take the current marker either from this to go to marker and take mark current and open. And if I place here, right, so the orientation is correct. So it will give me the current from left to right. But will it give me IX or will it give me IX minus IZ? That's my question. So will I get IX or will I get IX minus IZ? Or will I get IZ minus IX? Right? So if the answer is, if I get IX, it's wrong. I will be getting IX minus IZ. So where do I place to get IX? So to place IX, if I place at this positive, so somewhere here, if I place here, what do I get? Do I get IX minus I5 or IY minus IX? I get IX minus IY. Right? Now, then if I place the current marker at negative, then I get value for IX. Because current through 4 is nothing but IX, which is your mesh current. Okay? Now similarly, where do I place to get IZ? Right? So you can pause the video, analyze, and then you can check your answer. So to get IZ, I will be placing at this end of 10 nodes. Okay? Similarly, to find IY, where do I place? Now this is where you have to apply your concepts. Right? Now if I place my current marker on the wire, it will give me an error. You can see, I cannot place on the wire. I have to place the current markers at the end of elements. At the end of element. Okay? So I can place at the junction. Even there I am getting an error. You can see at the junction also we are getting error. You have to place only at the end of elements. So now if I place at this end, I get the branch current. It is, which current is it? Is it IZ minus I5 or IY minus IZ? So if I place the current marker at this junction here, this node, I'll get IZ minus IY. Because we know it will give me the current from right to left. It will give me the current from right to left. So this current, this orientation of current is IZ minus IY. Then where do I place? If I place here, I get IY minus I current. So if I place here, what do I get? I get IX minus IY. So where should I place to get IY? So you can pause the video, analyze. Right? And then you can check for your, once you have done your answer, you can just play the video and see. The right answer would be, I have to place at this branch, bottom branch. But how do I do that? When I place the current marker, it will give me an error. So I can't place a resistance. Right? So if I do that, let me show you. If I do that, is the circuit still electrically same to what we have done? No. I know you would answer saying that, sir, we'll make this as 0. Right? When we simulate, we'll get an error. Let me do that. So you have to click on transit. As this is DC, we need not worry about the time period. Because any value remains constant. So let us save and let us simulate. You can see here, it says value may not be 0. We have to give the value of resistance. So you can debate and say that the value of resistance can be given as small as possible. Right? But in that way, electrically the circuit will change. In that way, the electrical circuit will change. Now there are two ways of doing it. Either give the least value of resistance, or what you can do, I'll copy Control C. You can copy the voltage source. Control V is placed. You can do it in any direction, and I'll give the voltage as 0 volt. So if you give the resistance as 0 value, you can give a voltage source of 0, and then this current will give me I. What is the orientation current of current? Correct. Should I place at the positive or should I place at the negative? If you place at negative, it will give me in this direction, that is anti-clockwise, again negative of the answer. So we have to place it at positive. So the current will flow from this end to the other end of the same element. Okay. Now we have placed everything, but when you go to simulation, how do you know? We'll see what's your output now. So click on toggle cursor. We got 6.7368. So that's for which answer? That's for IY, right? And then what is this current? This current 1.738, and that is your answer for IZ, right? And then what else we have? We have the last one, 1.9, which is that 1.9 IX. You can see here it's very easy when you calculate. You can clearly see IX, IY and IZ. But in simulation, you cannot see it here. But let us say if you want to see, I want you to observe now, you see IV3, IR1, IV1, right? Instead of that, you can rename all these as IX, IY and IZ. So let's see how do we do that. So what you can do is, you can go to your simulation. These are the just undo everything. Now this V1 variable, we are trying to find the current where through V1, and that is my IX. So I will rename V1 as IX, and I will rename V3 as IY, and I will rename R1 as IZ. Now let us check your output. Yes, you can see we have got IX, IY and IZ. So IX is 1.9 something. And let's now see our results. Okay, let's click on toggle cursor. Now what is your IY? IY is 6.736. Yes. Let's see IX, click on this dot. So IX is 1.9123. I have used left click. If I right click, I'll get same. Okay, and what is IZ? So IZ is 1.73. I'll left click as well as right click, 1.7360. So this is how one has to simulate to find your currents. Now that we have found our unknowns, right, IX, IY and IZ. So what is the next aim of the experiment? One is to find powers. Okay, now let us find the power associated with 3 ohms. How do we do that? Power associated with 3 ohms. So let us try to zoom in 3 ohms. Right? So then you have to find IX minus IZ. So to find IX minus IZ, where do I connect? So let me zoom out. Let me zoom in this part so that you can see both IX and IZ. Yes. So this is your IX and this is your IZ. So where do I place the current marker to get IX and IZ? Now, what we can do is simulate. Now, where are we finding power? Power associated with this 3 ohm. What is the variable name? The variable name is R2. So you can go to the different way how you can do. I'll show you both. You can go to add trace. You can see this icon which says as add trace. Go to add trace, and then we need to find power associated with R2 for 3 ohms, right? So you can click once R2, and you know it is I square into 3. So this into, I repeat, plus into symbol, then once more IR2, and again into the value 3, and then say on, click on OK, and then got the output here, but let us see the value. Go to toggle cursor, select this IR2 into 3, you get 92.336 milli, which is same as 0.093 watts. Okay, so this is how one has to find power. Now, let me show you the other way also. What we can do is, you can simply find the voltage and current across it. Go to markers, voltage differential. So plus here and minus here. Okay, let's take a current marker and place here. Right, so where you have done all these things with respect to R2. Right, so let us simulate again. So as you simulate again, you can see you got R2 and I2. So V into I. So you can, what you can do is you can multiply the value of current here. What is that? Into the current I R2. And say OK. Go to power cursor and click on this, you will see the power. Or you can come to this, you can copy this formula. This formula is your voltage across the R2 resistance. You can select until here, copy, just Control C, and then click on this current, then again multiply simple. So you can see both ways it is true. So either in that way or go to add trace, you can type the formula, right? So let me do that. You can go to add trace. Now the formula is voltage. Where you will find voltage? Across R2. How? Resistance has two ends, 1 and 2. Colon 1, comma, R2 colon 2. Close the bracket. This is your voltage. Current I bracket, which current? Current through R2. And then type enter. So we've got it here. And you click on this, you can see I'm getting 92.36. So all these are different ways how you can find your power. Right. So now, after finding power, what else we have to do? We have to find the power associated with 6 amperes. How do we do that? Voltage into current. So let's go to the circuit. Now, this is how one has to find. So across 6 volt we find voltage, and how did we find? Top it was positive and bottom was negative in our theoretical calculations. So let us do in the same way as we are done in our theoretical calculations. Right? So let us delete all the rows because we have done that. We have simulated for all parameters. Now, so let us find the voltage across. This voltage is your node voltage. Okay, this is your like a positive probe. Negative probe by default is at the bottom. So all these will be used under nodal analysis to find your node voltages. Okay, do not use that to find your drop across the element. So potential difference, how top is positive, bottom is negative. Right? And which current? Current I1. Okay, so let us simulate this now. And what should we get the voltage as minus 13.368. Let us check our answers. So, yes, minus 36.368 is what we had simulated, calculated. Minus 13.368, and we are simulating also as minus 36.368. Now let us double click on this, and we know which current, it is I1. So, multiply symbol, and then I1. You can see here, this is I1. As you click, it will come here, expression. And click on OK to find your power. So you can see the formula is V into I, right? And the answer is minus 18.211. So this is how one can find the value of current and resistance power in your space. Right? So we have calculated and we have seen how do we find the value of resistance, non-resistance current, as well as power in simulation, and the values of theoretical will match with your